For this video, we will be discussing functions. And this is actually part 1 of 2. And in this video, all we're doing is we're going to get an introduction. We're just trying to determine what are functions. And using this information, we'll be able to determine if a table or graph is a function or not. So to begin, we have this. Functions are very simple. A function is a function if each input has exactly one output. No more, no less. And I want to first start off with this illustration right here. That functions don't necessarily have to be equations, like in the sense that we usually think of them. There's a lot of examples in real life that use functions. A function is just something that links one value to another. For example, let's say this is our function right here. It's our GPS. If we went on our phone or on our computer and went to like Google Maps, we would type in our address and the GPS does some work, and then you'd expect to get your house out of it. And that's a good function because every time you put your address, it will always get you to your house. It won't send you to McDonald's, or it won't send you to your school. It would always send you to your house. So that is a function. And this is seen here. Let's say this is your address and this is your house. It's a direct connection, a direct relationship. However, let's say if one day you decide to look up your address or an address somewhere, let's say your house, to keep this example the same. You type in your address, but one day it sends you to your house, and the next day it sends you to McDonald's, and the next day it sends you to some house out in a different country. That would be a terrible GPS. I wouldn't want to use that. So that would not be a function. And this is represented right here, where the input, in this case X, or in this case your address, if it sends you to 3 different, or more than one, it doesn't even have to be 3, it could be 2, it can be 0, it can be a million. If it sends you to different outputs, it is not a function. One last thing I would like to point out is you can do the opposite. While you only want one X going to exactly one Y, one input going to exactly one output, you could definitely have multiple inputs going to the same output. And I'll use this example again. If you type in your house and your GPS was really smart for whatever reason and you had named it, your GPS could send you back the address, it could send you back a name, it could send you back a whole bunch of information based off of that name. And that'd be a really good function too, because multiple things link to the same output. Now, the most important is that you get this, that each input has exactly one output. And this is also, sometimes you'll see this depicted like this, where each input goes to one output. So now we're going to take what we just learned about functions, and now we're going to see an example. We're going to determine if a table is a function or not. So here I have this example. We have this table, this function. Well, we're trying to determine if it's a function or not. And we have all the inputs, all the X values, which are 0, 1, 2, 3, and 4. And the outputs, which are Y values, which are 8, 4, 2, 1, and 3. So I went ahead and took these out of table form to see the relationships between the inputs and the outputs. So we have 0 that goes to 8, 0 goes to 8, 1 goes to 4, 2 goes to 2, 3 goes to 1, 4 goes to 3. And as you can see here, every single input goes to exactly one output. So this table is a function. Now, this relationship, all this means is that when we plug in 0 to our function, we're going to get out 8. When we plug in 1, we're going to get out 4, and so on and so forth. And this is basically the example from the previous little clip, where if we plugged in our address, we expect to get our house. Our next example is this one here. Here we have our inputs again, our outputs, and I went ahead and took it out of the table to show the relationships between the inputs and the outputs. So here we have 0 goes to 1, 1 goes to 2, 2 goes to 1, 3 goes to 3, and 4 goes to 4. Now remember what we said about functions, that each input has to have exactly one output. Here we can see 0 has exactly one output. It goes exactly to 1. 1 goes exactly to 2. 2 goes exactly to 1. 3 goes exactly to 3. 4 goes exactly to 4. None of these inputs go to multiple outputs. Therefore, this table is also a function. Again, this was that example where it's okay to have outputs that go to multiple inputs. Remember, we only care about the inputs going to exactly one output. For our final table example, we have this table here. Our inputs are 0, 1, 2, 1, and 4, and our outputs are 4, 3, 1, 8, and 5. Again, I showed these relationships here. 0 goes to 4, 1 goes to 3, 2 goes to 1, 1 goes to 8, and 4 goes to 5. And if you see, this 1 here goes to 3 and it goes to 8. Therefore, it does not meet that requirement of each input going to exactly one output. As a result, this table is not a function. Now, if we were to erase either this one or this one, then the table would become a function because the 1 would no longer go to 2 outputs. Now, we've seen how to determine if a table is a function. Now we're going to move on to graphs. And we have this thing called the vertical line test. And it sounds pretty self-explanatory. We take a vertical line. Here we have this blue line is our function. And we're trying to see if this line, this green line, touches the blue line at exactly 1 point throughout the entire graph. As you can see, it only touches where my finger is pointing. Therefore, according to the vertical line test, this graph is a function. Here's another example of a graph. We have this blue line, and if we do our vertical line test again, we can see now that it touches at 2 points. And as soon as it touches 2 points or more than 1 point, we automatically know this graph is not a function because it did not pass the vertical line test. And to connect this to the table from earlier, let's say we have this x value of 1. And let's say this is a y value of 3, and this is a y value of -3. Well, that means that this x value of 1 would go to 3, but it would also go to -3. Therefore, we can see that this graph, based off of the vertical line test, is not a function, but now we can see if that we had it in a table, it's still the same idea. You have one input going to 2 different outputs. For our final example, I wanted to show this weird looking graph. So we're going to do the exact same thing, use the vertical line test, and we can see that right now it's meeting the criteria. It's only touching 1 point, and it touches 1 point throughout, except once we get right about here, we can see that it touches 2 points. And as soon as it touches more than 1 point, it automatically fails the vertical line test. Therefore, it is not a function. So it doesn't matter that it only touched one point up to here, it was only touching one point. As soon as it touched those 2 points, then we know that it's not a function. However, if we were to cover this up and the function was this curve right here, then it would be a function. To recap, functions, they're a relationship. They describe a relationship between input and an output. Remember, functions have each input going to exactly one output. And to see this in a table, we want to make sure that every input, every x value, goes to exactly one y value. It's also okay to have a y value that goes to multiple x values. But here in this last example, we have an x value that goes to multiple y values. We have one input that goes to more than one output. For graphs, we apply the same concept using the vertical line test. And if we do a vertical line across this function, and it only touches once at every point, then it is a function. Otherwise, if it touches 2 or more times at any point, then it is not a function.